It's the Unknown Mechanic back again. And this channel is for the shop owner who has subpar technicians that fumble and bumble their way through a job and every 5 minutes have to come ask their boss a stupid question. And it's also for the aspiring mechanic who does want to raise their level and proceed through a job start to finish without making mistakes. And it's also for the do-it-yourselfer homeowner who may want to try to tackle a job like this on your own, or at least see how a professional would do it with the proper tools and techniques. So, if you don't want to do this job on your own, at least you're educated when you do take it into the shop what the proper methods and tools are and what you should expect to pay and the proper repair methods. So today we are working on a very old Toro 19-inch Guardian lawnmower from 1977, and it's got a Briggs and Stratton engine on it, and it belongs to Gladys Hydrangea, and it says when mowing hit a tree root and engine stopped, could not restart. Turned it over to a nephew, and the nephew tried to repair the ignition and repair the carburetor, replace the flywheel key. Mower started briefly but was vibrating badly, shaking badly. So call with estimate and check over. And so anyway, one of my other techs, Einstein, he looked at this and determined that the crankshaft is slightly bent, and that's bad. When you bend the crankshaft on an engine on a rotary lawnmower, it's going to be out of balance, and even if you do repair it, the machine is going to shake. And depending on how bad the crankshaft is bent, it could actually be very dangerous. So the first thing we want to do, we do not want to do any kind of a repair until the crankshaft is addressed. And obviously the best way to repair it is replace the crankshaft. But unfortunately, this engine is so old, the crankshaft is no longer available. It's obsolete. And the second alternative would be to replace the engine. Now, I went over all of these things with the owner, and she's on a fixed income Social Security and loves the lawnmower, and isn't going to mow the lawn for that many more years. Doesn't really want to make a giant investment in like a new battery lawnmower. The gas lawnmowers are banned where we are, so we've sold out of them, and we have battery electric now, Honda and Steel and so forth. And they're pretty pricey, and they're kind of, one of the mowers that was in her range was a Steel RMA 460, and unfortunately Steel is replaced that or updated the model to an RMA 348. It comes in push or self-propelled, and of course the price point is higher, and that's just kind of out of her budget. Replacing the engine would be a possibility. I might be able to put a Honda GCV 160 engine on this mower. That might be difficult because this is a shorter crankshaft, and the standard crankshaft length is longer than this. This has got a stubby crank, and So really the option we're going to try, I did not promise her that this was going to be successful. We're going to try to straighten the crankshaft. And most manufacturers frown on that because you can, metal fatigue the shaft and, get some stress fractures going in it. And eventually it could fail, and that could also be very dangerous. But I took a look at this, and Einstein made it sound like it was a disaster. But when I pull the rope on this thing, I can hardly see a wobble at all. It is only very slightly bent, very slightly bent. So there's a very good chance that it's not going to take a lot to push that crank back and reuse this engine. And that means that it's not going to be too costly because I don't have to separate the sump cover and unbolt the connecting rod and take the flywheel off and then put a brand new crankshaft in there and a new gasket and torque the rod bolts. And that's a bigger project. If I can put this engine on the crankshaft straightener and just push it a little bit, I think it's going to be good to go. So what we've got here in the way of the tools is this is a Model 4AX shaft saver. It's made by the Little Brute Company in Monticello, Iowa. And I'm sure this company is out of business. If you needed a crankshaft saver, I think there's a more modern one called a Little Giant that is available. I don't think that these are available anymore. But that's what I have, and that's what I've used in the past, and that's what I'm going to try on this one. And it's got a push screw, and it's got a indicator needle, which will get you in the ballpark. When I do my finish pressing, I put a magnetic base and a dial indicator and go directly on the crankshaft, and I try to get it within, a couple of thousandths, which is much more accurate than this needle and scale. So first thing we need to do before I mount this on the crankshaft straightener is I have to remove the blade hub, and the blade hub appears to be bent, and I've already prepared for that. I've looked up this blade hub, and we actually have one in stock. And I've also looked up a 19-inch Guardian blade, and we have one in stock according to the computer. So if the blade is bent, we're going to replace it. This blade hub is not that expensive. I'm probably going to put a new one on there. I don't know if I'll try to straighten this out or not. It's so cheap that I probably will just put a new one on. It's about $10. So in order to get this hub off, what we need to do is have a push screw. Got a collection here for pulling blade hubs off of rotary lawnmowers. This is a 7/16 bolt. It's not a 3/8. And thread this in here. Get a lot of engagement. And then I've got a snap-on 2-jaw puller. And I picked the right style of jaw that I want to use. It's going to go right over this sheet metal part and go right onto the hub, which is solid steel. If you try to pull on the sheet metal part, you're just going to bend it. So this is a better way to go. This puller is pretty nice because you can move the jaws into two positions, an inner position and an outer position. And I'm probably going to go with the inner position. hopefully this thing will come off. When I get this sort of hand tight, I'm going to move it around so it's in better view of the camera. Okay, I hope you can see that. Looks like we're pulling on the key. I'm going to turn it a little bit. There's a Woodruff key in there, and I don't want to pull on that. Okay, that's better. Okay, so I don't know if it's hard to see, but there's a Woodruff key in the crankshaft right there. So my puller jaw is on top of the key, and I don't want to pull on the key. So I'm on the hub only, and I'm not pulling on this sheet metal part that holds the blade. Yeah, that came off. So that wasn't too difficult. So this is the part that I'm going to replace. And I'm going to remove that Woodruff key. It's not broken. It just bent the shaft a little bit rather than break the key. And the other thing I'm going to do is I'm going to get some emery paper, and I'm going to de-rust and clean this crankshaft. And then I'm going to bolt this up to the shaft straightener, and we're going to proceed from there. So I'm going to pause because I don't want to make the video too long, and I'm going to come back when I've got this clean and mounted onto the shaft saver. Okay, I've mounted the engine on the shaft straightener, and because this is a short, stubby crankshaft engine, the shaft doesn't protrude far enough so that the pressure screw is able to push on it. So most of these shaft straighteners come with an extension sleeve. And I've put a couple spacers down in there. And when I put this on here, it bottoms on the end of the crankshaft rather than rubbing on the oil seal and the sump area where the PTO comes out. So I can snug it up with a longer bolt, and then I'll be ready to use it to straighten the crank. Now I'm going to undo the indicator needle, and then you can watch it, and you can definitely see the needle move. Probably about three lines there. Definitely has a wobble, but I've seen a lot worse. So we're going to put a little piece of blue tape on this. And I'm going to take a Sharpie and mark it. Okay, and I'm going to push on it and see what happens. I'm going to watch the indicator needle, and you have to over bend these. They're springy. You have to bend them farther, because if you just bend them straight, they'll just spring back. So we're going to try to bend this maybe 3 lines. And see if that did anything. Well, it's better. When I make these videos, I usually go onto YouTube and I see what else is out there, and I just don't want to make a Me Too video. And what I found when I checked out some of the other ones is that people were advocating just beating the crankshaft with a hammer. Now, if you don't have shaft straightener and there's no shop in the local town with a shaft straightener, and you know you're out, you know that's the alternative you have to do. The problem I have with striking a crankshaft with a hammer is that what if you hit it too hard and you bend it too far, and then you turn it the other way, and then you try to judge, well, I'm going to hit it half as hard. It's very difficult to judge how hard you're hitting something with a hammer. The pressure screw, you can look at the indicator and count the number of lines that it moves. So we're going to go 3 again. And I've also seen, you know, people try to, you know, put a big pipe on the crankshaft and bend it that way. That might be better than trying to use a hammer. But it's still not as good as this method. This is the best. The only thing that's better than this is replacing the crankshaft. And we're still a little high over here. So 3 lines, it bends it and then it springs back. So I'm going to try to go 4. Just a tiny bit more. That's pretty damn good. I think we're still a little high on the blue mark. That's very good. That's the best I can do with this primitive indicator needle. The next step is a magnetic base and an actual dial indicator. And we'll see what we can do with that. Okay, I have decided to edit out all of the bend, measure, repeat process. It's very repetitive. We don't need to make the video longer than it needs to be. You get the idea how this works. I went as far as I could with the onboard indicator, and when I was satisfied with that, I disabled it, and then I mounted my magnetic base and my dial indicator for much greater accuracy. I've also removed the blower housing so that I can turn the crankshaft in a really slow, controlled way. And you can see that there's very, very little indicator movement, 1 or 2 thousandths. I'm going to bring this in for a close-up. And you can see that I'm indicating very, very near the end of the crankshaft. Too far in and it will drop into the keyway. Too far out, it'll be off the end. And what I'm going to do is I'm going to slowly turn this 360 degrees. And you can see that the indicator is moving only 1 or 2 thousandths. Okay, that was a full 360 degree turn. And you have to keep in mind that even a brand new engine will have factory tight clearance in the main bearings, maybe only 1/1000th of an inch. But an old worn high mileage engine, it's going to have more wear in the bearings. And I'm very satisfied with what we've got here, and I can proceed. And what you don't want to do is beat on the crankshaft with a sledgehammer or put a pipe on there and bend it with a pipe. This is the proper way to straighten a bent crankshaft. Those hillbilly methods, that's not what a professional shop would do, and this is the proper way to do it. So the next step is I'm going to remove the magnetic base and the indicator. I'm going to turn this around, and the customer replaced the ignition coil. And one thing that you got to make sure is that if anybody does some work to it, anybody else does work, you want to recheck that work and make sure that it was done correctly. So he replaced the coil, and I don't trust other people's work. So I'm going to pause the camera and we're going to flip this around and look at the ignition. All right, we are ready to start looking at the ignition, and I can see a brand new coil here. First thing I'm going to do is take off the blower screen. And I see a problem. There's a broken flywheel fin. The customer was probably using the improper tools to get the flywheel nut off. I've got some of the tools here. This one is an aftermarket one. It says Taiwan on it. And it would fit in that manner so that you could use a 1/2-inch breaker bar to get that 15/16 nut off. Got one of the original ones here. This one's a real antique. It's cast bronze, and it's got the Briggs 19167 part number on it. This is very, very old. The more current ones are cast iron. Then some of these engines have a starter clutch. They don't use a vertical pole start. They use a starter clutch on the end of the crank, and you have to have one of these clutch removing wrenches. This enables you to use an impact gun to take the clutch off and then use a torque wrench to put it back on. Don't need that in this case because there's no starter clutch. You just got one big nut. So I've got my impact gun set up with a impact socket, 15/16 deep. And I can already see another problem. This is a standard flat washer. These engines are supposed to have a Belleville washer that is domed or crowned on the top and dished or concave on the bottom. And they're like made out of spring steel, and they retain the torque. This nut's supposed to be torqued to, I think, 55 foot-pounds on an aluminum flywheel, and some of the other engines that have cast iron flywheels, I believe it's 60. I'll be checking that when I go to put this back. With a broken flywheel fin, that probably will reduce the cooling air just a few percent, but that's not a big issue. The big issue is that with a missing fin, this flywheel is out of balance. When they manufacture these at the factory, they drill holes on the heavy side and balance them. And I think what I'm going to do is, go through my junk pile and see if I can find a flywheel that's not broken, and swap flywheels out. So I do also see that this coil does not look like a Briggs and Stratton coil. This looks like some kind of a Chinese Amazon thing. And it's the wrong coil. The curve on the legs of the armature does not match the curvature of the flywheel. So this flywheel's got magnets on one side and it's got counterweights on the other. And if I bring the camera in for a close-up, I think I can show you what I'm talking about. If you see out here, the gap is much larger than on the inside of the leg. So the flywheel that's intended for this coil is larger in diameter. So that's definitely, this is not going to work. And it also looks like he's got the ground wire running around here and then underneath the flywheel to where the points are. In a 1977 vintage engine, Briggs and Stratton had not yet developed electronic solid-state ignition, and they were using a standard coil with points and condenser. And then in the 80s, they came out with a retrofit kit that would backfit their point coils, and you would push that onto the armature legs, and you would twist some wires, solder it, and then put some silicone sealer on it to weatherproof it. And that would allow you to eliminate the points. The points are under the flywheel. I'm going to have to pull this wheel in a moment. But that very first version that Frankensteined onto a point coil to eliminate the points, the problem with that was that the timing was inaccurate, and by installing that you would actually get a horsepower drop because the timing was off. It did eliminate your points and you never needed to do a tune-up, but the engine produced less horsepower. Since then, they superseded to another coil, and that was superseded to another coil which is current. And I'm going to have to look up that coil and see if we've got one in stock. But right now I'm going to try to pull the flywheel off. And in order to do that, you need a flywheel puller. Got one of the current ones. It's a 19165. It's made out of cast iron. It's got longer screws. Got one of the original ones. This one's made out of steel. And what you need to do is, it's even marked on the flywheel that there are arrows pointing towards these two puller holes. And it says use the puller holes to remove the flywheel. You don't want to pry on this or use a 2-jaw, 3-jaw outside puller. You could bend, crack, damage the flywheel. So you have to thread these two holes, and the screws that come with these pullers are self-tapping. They will cut their own threads. And sometimes I don't like to just force those in there. I have a 3-piece tap set with a bottoming tap, a plug style tap, and a regular taper tap. And I would, cut the threads in the flywheel with a bottoming tap. But this one's already been pulled off and it's got threads in it. So I can skip that step. And what you want to do is thread the flywheel nut back on here till it touches, and then back it off a turn or two. And then put this puller on here. Turn those screws in until they bottom. And then these nuts have to be progressively tightened. Oh, that came off easy. That would indicate that he probably did not properly torque this flywheel nut to its final tightness. Flywheel's loose. Pretty sure that the aluminum wheels this nut's supposed to be tightened to 55 foot-pounds, and some of the iron wheels that are the same size engine are supposed to be tightened to 60 foot-pounds. I'm going to be checking that when I put this back together. And I will be using a torque wrench and one of these flywheel holding wrenches to tighten this nut correctly. Okay, the key is intact. This looks like an aftermarket key. That's not a Briggs key. When they went to electronic ignition, they changed the hardness of this key. These keys for a point ignition engine are very soft, and they're designed to shear if the lawnmower hits a tree stump or tree root or sprinkler pipe, like this one did. The key will shear when the flywheel shifts position. And when you graduate to an electronic ignition, the ignition timing is no longer controlled by the point cam ground on the flywheel side of the crankshaft. The ignition timing is now being controlled by the keyway in the crankshaft and the keyway in the flywheel, and a harder, more precision fit of this flywheel key. So I'm going to take this off. And yeah, there's points and condenser in there. And he's got this electronic coil hooked up to the points. That's totally wrong. We are going to remove all of this. We are going to remove the breaker point plunger and seal it with a plug, and that'll all be gone. And we're going to put the proper coil on here, and then we're good to go. Now, another thing I see wrong with this is the governor link is bent. This governor link is bent. I'm going to have to replace it or straighten it. That's not supposed to be like that. It's supposed to be more straight. So I'm going to pause the camera and I'm going to go look up an ignition coil, and hopefully we have the right coil in stock, and we'll come back and update the ignition. Okay, I've gathered up some of the tools I think I'm going to need and found some parts. First thing I'm going to do is strip off the old ignition, get rid of it. We're going to remove and disable the points. Don't need them anymore. I'm going to remove the breaker point plunger, and this is the replacement coil. It's a part number 591420, and it comes complete. There's an air gap gauge for setting the air gap. And what I'm looking for right now is the plug to seal the point plunger hole. If you don't seal that up, you will have an oil leak. The ground wire for the kill switch has to go through this hole. If you put it through the other hole, it probably will cut through the insulation and ground it out. This hole has got a relieved edge and is not sharp, so it won't cut the insulation. And these coils are marked. It says this side out. So we're going to put it on this way. If you put it on backwards, it's not going to work. One of these wires we don't need, so we're gonna cut one of them off. And for now, I'm going to move the coil as far up as possible. We will set the air gap after the flywheel is torqued. This wire is probably going to have to be shortened, and that's why there are extra terminals included with this coil. There's a 0 degree and a 90 degree. We're going to be using the 90 degree. And there are full instructions. Here it's talking about there's 2 ground wires, one with a spade terminal and a ring terminal, and one with no terminal. It says pick the right one and cut the other one off. I've already done that. These are the instructions for shortening the wire and crimping the spark plug terminal on. I'm going to be following that. And this also doubles as the air gap gauge. And as I mentioned earlier, this family of engines, just like I thought, it's 55 foot-pounds for the flywheel nut torque. And I've got my torque wrench here ready, already set at 55. And here it's just talking about leaving the points in place. That would be the quicker, dirtier way of doing it. The more thorough way of doing it is removing them and using the plug and preventing oil from leaking out of the plunger hole. A little bit cleaner way to do it. And I'm going to put the dust cover back on, even though there's nothing under there anymore. Okay, now we're going to put the flywheel back on. And I had noticed that the customer had broken off one of the flywheel fins, and he had also used a standard regular washer. He had lost the correct washer. So I was able to find the correct flywheel, a used one, and the correct washer. This washer's got a cone on one side and a concave on the opposite side, and it's made out of spring steel. And when you torque this flywheel nut down to 55 foot-pounds, that washer flattens out and it helps retain the torque and prevent the nut from loosening. It's like a spring washer. So also the flywheel key, as I mentioned, the timing is no longer controlled by the points. The timing is now controlled strictly by the keyway in the crankshaft, the keyway in the flywheel, and a more precise fitting flywheel key. So this is not going to move. It's a harder key than the earlier key that was used when there were points in there. And then we put the washer with the cone side up. And I'm going to get a cheater bar from my wrench. Okay, the flywheel is now torqued to 55 foot-pounds. I'll put the rotating screen back on. Okay, that's pretty good. Now it's time to set the air gap. Okay, this side is just a counterweight, no magnet. That's the magnet. So I'm going to put the magnet underneath the legs of the armature, put the air gap gauge in there, loosen the screws, and the magnet sucked the ignition coil right up to the air gap gauge. I'm going to push down and tighten the screws. Two different sizes, 1/4 inch, 5/16. Now we can remove the air gap gauge. And as I mentioned, this governor link was bent. Okay, so I'm going to straighten that out. Okay, that's how it's supposed to be. Okay, that's much better. So it's got an air vane governor, so it will prevent the engine from overspeeding. These governor springs, there are many different part numbers for them. They're calibrated for the maximum RPM, top governed RPM. And this one, it appears to be in perfect condition, unlike the governor link. The governor link was damaged, but the spring is good. I'm going to shorten this wire and connect it to the stop switch. just got a release here. You pull that release and the wire comes out. And it only needs to be about that long. And that stripper's not going to work. I need my other wire stripper. And there's our ground wire for the kill switch. So I think I'm going to shorten this one off camera just to keep the video shorter. And then I'm going to put the starter back on. I'm going to put a spark tester on there, turn the lights out so it's dark, and we'll test this for a spark. And so I'm going to pause camera and come back when I'm ready. Okay, I have the lights turned off. I have not shortened the wire yet because I wanted to leave it long for the spark test. And I have got my control on run or high speed. And so we are going to bring the camera in for a close-up. My spark tester. I'll pull the rope and see what happens. Now we're going to repeat the test. We're going to turn the control to the off position and see if the stop switch works. Should be no spark. So I think we're good. And the engine is pretty much fully assembled. The next step is to sharpen and balance the blade, mount a new blade hub on, mount the engine back on the deck, and check the oil, the gas, and see if it starts and runs. Okay, we have the engine mounted back on the deck and the blade mounted back on, although not sharpened and balanced. I'm going to see if the engine starts and runs, and if it does, I'm going to shorten the ignition high tension wire and sharpen and balance the blade and check the oil, add, change as needed, and we'll see what happens. Okay, carburetor a little out of adjustment. Top governed RPM, a little too low. Raised it to 2,500. I'm going to sharpen and balance the blade. And when I test run it the final time, I'm going to lower the idle to 1750. So I'm going to pause for now, sharpen and balance the blade next. Okay, I've got the blade off, and I'm going to check it for bends. If it's bent, we have to replace it. If it's not bent, we can sharpen and balance it. This is a Magnamatic blade balancer. It's got very strong magnets and very precision ball bearings. Can easily detect an out of balance blade. And this side's heavy. Okay, and then you could turn this sideways, and this antenna is adjustable. Okay, so we're going to rotate that 180 degrees, and the blade's not bent. Both blade tips are probably within a 1/16 of an inch, maybe a 32nd of the indicator. You can bring this in for a close-up. Okay, there's one side. There's the other side. So we're not bent. But this blade is out of balance. This side is heavy. And so what I'm going to do, so I'm going to mark that side, the heavy side, and I'm going to try to grind more off of that one. So I'm going to pause the camera and we're going to go out to the blade grinder. Okay, we're back in the shop. I have only ground one side, and I've left the heavy side for last. You can see that it's way out of balance now, but that's because it's only half done. I'm going to bring you in for a close-up so you can see the before and after. Okay, that is the after. So it's very sharp. And that is the before. It's very dull. So back out to the grinder and I'll come back to see if it's balanced. Okay, I've ground quite a bit off the heavy side, and now you can see that it's like pretty much perfectly balanced. That's about as close as you can get it. And I'll bring you in for a close-up. Okay, so the heavy side came out maybe even a little bit better than the light side. One thing you want to do is, check a straight edge on your grind and make sure you don't have any valleys or crowns. I've had a lot of crappy mechanics that work for me. We had Secret Agent Man and the Big Asset, and Sniffles and Gomer and Dingus and Speedy and Einstein and Scratch, and none of them can grind a blade worth a damn. Scratch, he had 40 years experience, and he ground a lawnmower blades like a kindergartner. So I was never very impressed with Scratch. So we are going to put this back on, and I'm going to shorten the high tension wire, and I'm going to lower the idle speed down to 1750, and then this mower is done. So you've already seen it run. I don't think we need to make the video longer than necessary. You know it's going to run. You know the blade is sharp and balanced. You know the carburetor is going to get a final adjustment. I think we're going to call it. So if you like the video, thumbs up and subscribe to the channel. Watch all my other videos. Leave some comments. Nobody leaves any comments, so I don't know if I'm doing a good job or a bad job. And we'll see you on the next one. I don't know what it's going to be. So it's the Unknown Mechanic signing off.